Okay, so again, when we're talking about frequency distribution, remember that is just another way for us to organize our data into, a table basically. So I just wanted to show you a couple examples that we had in our handout. So here, we're just starting out with a basic example. They're talking about the ages of the top 50 wealthiest people in the United States. So, they've got those 50 ages listed. So when we're talking about a frequency distribution, we're saying we're organizing our raw data into a table using classes and frequencies. Now, when we talk about creating these classes, it really depends on your data. So a lot of times, your classes can be in this form where we call them as class limits, right? You have a lower limit and an upper limit. So in this case, we are saying the lower limit is 27 and the upper limit is 35. So anybody who falls in the age of 27 years old to 35 years old, all of those people will go into, that class. Anybody who falls into the age group of, 81 to 89, they will fall into that class limit. So that's one way of doing it. And then, we can have examples like this one. This is also a frequency distribution example, but this is a categorical. So you can see this is not really based on numbers per se, but more about what blood type you have. So you can be A, B, O, or AB, right? So 4 different blood types. And so you can see in this case, then you're just creating your classes based on those 4 categories. And then, of course, you will do your frequency based on that. And then you can calculate your, percent, or you can calculate your relative frequency and everything else after that. So you can have 2 different types of frequency distribution. So this one with the blood types is what we call as categorical. And then the grouped frequency distribution is, where you saw the ages of the 50 wealthiest people, or this example over here. So you can see, again, we have, instead of just having classes, we have class limits. So this example here was talking about record high temperatures for each of the 50 states. So what happens in this case, especially where you're using grouped frequency distribution like we are over here, you have to decide on the number of classes. How many classes can you have? And you can see we are talking about there should be anywhere between 5 to 20 classes, which means you don't want to have each of your classes be less than 5. So, we're talking about these. These are your classes. So there can be 5 of them or a maximum of 20 of them. So nothing smaller than 5, nothing bigger than 20. And it will depend on your data. So if your data is not very big, then you probably don't want to have too many classes, right? If your data is really big, then of course we would go with more classes in there. And the other thing, when you're creating these frequency distributions, especially of course the grouped ones, there should be no overlap between your classes. So what that means is if your upper limit for this class is 104, then this next one cannot start at 104, because if you did 100 to 104 and then you start at 104 to whatever, let's say 109, well, if somebody falls right at that 104 value, so the temperature, let's say in 2 different states, or even one state was at 104, do you put that state in here, or do you put that state in here? So where would you place that value? And that's the reason why we cannot have overlap. So since the first class ended at 104, the next class has to start at 105. Now you can also see next to it, we have class boundaries, and not all textbooks do class boundaries. For that matter, I believe your textbook does not get into class boundaries, but this one over here was, if your data value will have decimals in it, then this kind of helps you break down, where the decimal would fall. So anything, 104.5 and smaller, to 99.5 would go in here. But anything, even though this has an overlap here, this is a class boundary, right? It's not a class limit. So anything that would be larger than 104.5 to 109.5 would go in here. And that's kind of the reason why you will see a lot of textbooks don't like to talk about class boundaries. So we're just focusing on class limits over here. So remember, these guys cannot have an overlap in them. So 109, you will see then this guy starts at 110. So there will be no overlap between your class limits over here. And that is actually something you have to decide looking at the data. So nobody is going to give you, a specific number of classes. Now, your examples in the homework and textbook might say, create 5 classes, create 8 classes or something like that. But if it was data given to you in real life, then, obviously there's going to be no instruction on how many classes you have to create. So that's where your own idea will fall into place, how many classes you want to have in there. Come on, buddy. So remember, your lowest class limit is, going to be the smallest data value that can be included in your class. And normally what I say for your lower class limit is look at your data set, and whichever one is your lowest data value, use that as your lowest class limit. So our lowest data value in our set came out to be 100. So you will see we are using 100 as our lowest class limit over here. So whatever is the lowest class limit in your, or class lowest data value in your data set. So you can see 100 is our lowest value. You will see all of these are 3-digit numbers, because anything smaller than 100 would have been, 99, 98, one of those, or something smaller, 2 digits. So you will see there are no other 2-digit numbers in here. So 100 definitely is a good lowest data value that you can look at. And then whichever one is your largest data value or highest data value, make sure when you create these classes, so we have 134, either you can end at 134, but you can end higher than 134, as long as in that last class, 134 is going to be part of it, so that we have a place to put that 134 in our frequency column. So just make sure that your last class value, whatever this upper class limit is going to be, just make sure it will have room for whatever your highest data value is going to be. So you always want to make sure you have that in there. So the first thing you do is, once you are given a data set, is start by identifying your highest and lowest data values. Then we calculate the range for our data set. And we will actually talk a little bit more about range when we get into chapter 3. But basically the range means how far apart are your data values. So you take the difference between the highest and the lowest data values, and that gives you a basic idea of how spread out your data is. So, of course, if you're going from 100 to 134, that's a spread of 34 numbers, right? So the different values we have are going to be spread out from each other, from 100 to 134. So that gives us a range of 34. Now they're in this example asking us to use 7 classes. So, you take your range and you divide it by your number of classes to calculate your class width. So you can see we are taking 34, we're dividing it by 7, and this comes out to be 4.9. So this one gets rounded up to 5. And we always round up. So even if this number had come out to be, let's say 4.1, we would have still rounded it up to 4.5. So you're not using your traditional rounding rules. So keep in mind, you're always rounding up. So you're not doing like, if it's 0.5 or more, you go up. If it's less than 0.5, you go down. You're not using that for class width. Always round up. So even if, like I said, you had come up with 4.1 instead of 4.9, you would have still gone up to 5. So always round up for your class width. And how we know that our class width is 5 is look at the difference from the lower class limit. So you can see when you go from 100 to 105, that's a difference of 5 units. When I go from 105 to 101, that's a difference of 5. 110 to 115 is a difference of 5. So that's where your class width is going to show up at. So you're not really looking at the class width as going from lower to upper. So you're not looking at the difference between 100 and 104. You're looking at the lower class limit from the first class to the second class, or second class to the third class. And that's how, or you can do it with the upper class limits also. So 104 to 109 is 5 units. 109 to 114 is also 5 units, so either compare the lower class to lower class or the upper class to upper class for your class width. And then they're just kind of getting into a little bit more explanation on that. So this is kind of one of the basics, where you start out with when you are creating your frequency distribution. Now, once you have all your class limits taken care of, you can see they're bringing in a tally column over here. Now you can do the tally column, separately as scratch work, but really the tally just helps you come up with, how many states had a temperature that fell between, 101 to 104. So there were 2 states who had that as their highest temperature. You can see there are 18 states which had a temperature going from 110 to 114 degrees Fahrenheit. There was just 1 state that had a temperature recording of 130 to 134. So, the tally just helps you come up with your frequency distribution column. So what I thought we could do is, I have this example over here. It's just a silly example I found, but, I thought with the whole, oh my God, Avengers and everything, movies kind of coming out in these last few years, we would just use an example based on that. So this is just giving us different superheroes, and this is a data set I found on StatCrunch, and I just thought, this would be fun. And they have, lists of people that I'm not even familiar with. So you can see it's a pretty long, lengthy list. They've got it in alphabetical order. So there's like a total of, I don't know, like 700 some superheroes in there, and they don't have all the details on everyone, but for some of them, they have the height and the weight, and we're obviously looking for numbers to try and do these calculations. So let's go ahead and pick like the first, I don't know, we'll use the height for the first 100 superheroes that are on our list here. So I'm starting at number 6. So I would need to go down to 105. And you can see there are some gaps in here. So not all the information is available, but whatever values we come up with, we can try and use that. So I'm just going to go ahead and paste that in here. Will it let me paste and... Okay, so it won't let me remove the empty gaps. That's fine. We can still do our calculations based on that. So, of course, we don't have a total of 100 data values over here. But if you wanted to know how many total data values you have, you can obviously count the numbers, or you can actually use the count function that's built into Excel or even Google Sheets. And I'm using Google Sheets over here right now, and we can go down to our last number, which hopefully will be around 100. So we've actually only got 67 data values in there, because you can see there are so many gaps in here. So that tells us, how many total data values we're dealing with, which is still a very decent data set if you think about it. Now, if we wanted to calculate what our highest and lowest data values were, so let's do our highest and lowest data value. And for this, again, you can, one thing you can do is sort your column, going from smallest to largest, and I am not sure if it will let me do that, but we'll try, because I think it tries to sort out the entire sheet instead of just the column itself. But you can see our smallest data value is showing up to be 61, and the largest one is showing up to be 257, right? So 61 and 257. But I'm actually going to undo that because I want to have my little calculation over here. So the other thing you can do is, if you don't want to sort out your sheet, you can use the maximum function. So you can find the maximum value in your data set. And again, we went from A1 to A100, which were these cells over here, where I pasted all my numbers, and you will see it comes back with the same 257 that we saw when we sorted out our list of numbers over here. Whoa. What did I do? Okay, and then, you know, like you have the max function, you can use the minimum function to find the lowest data value. So I'm just going to change that to minimum. Remember that number was 61. So you can use, you know, Excel or Google Sheets to kind of help you out with some of these calculations. You don't have to do it by hand. But remember, our goal is basically to try and create our little frequency distribution over here. So right now, all we have is the highest and the lowest data value that we have found out. Now we want to calculate the range. So to calculate the range, you take the difference between your largest and the smallest, right? So that will be our highest data value, which was 257. And from that, we'll be subtracting the smallest data value, which was 61. So again, I'm just clicking on the cells. You can actually type in the numbers if you like. But again, just using, you know, Google Sheets to help us do the calculation for us. So, and you can see that's a pretty big range, right? Because the shortest height we have is 61, and the tallest height, I guess, in this case would be 257. So they're spread out by a difference of 196 numbers. So since we have 67 data values, if you had to choose between the number of classes, would you do, because remember you have to choose anywhere from 5 to 20 classes. So just kind of looking at the information we have right now, how many classes would you go with? 5, 6, 7, you know, 10 more? What do you think would be kind of a reasonable place for us to start with? Because, you know, this will be something you guys are going to be working on next week. Start small is what I say. Look at the answers you come up with. If the answers look like they need to be spread out a little bit more, then increase your number of classes. So for now,
well, the range divided by the number of classes only comes out to like 3 something.
Yeah, so you kind of have to choose, you know, what those classes will be.
Yeah, so I would double that to 6.
So you want to do 6 as your width or 6 as your number of classes?
6 is the number of classes, because 196 divided by 67 is somewhere in the 3 range. Not enough classes to be over 5.
Okay, so we're taking our range, dividing it by our number of classes, and it's coming out to be a width of 66666. Okay, let's see what happens if we change that number to a little bit higher. What if we made it 8? And you can see this is one of the reasons why I use cells instead of typing in the numbers, because when I change my value here, you know, it automatically calculates the new width for me. So just again, as a argument, you know, let's say we did 10 classes. So you can see this is coming out to be 19.6. Now, guys, remember, no matter what, you always round up. So this will become 20. Okay. So for now, let's say we're staying with our number of classes as 10 and our class width is coming out to be 20. So now when you start creating your frequency distribution, we're going to start with our class width, and I'm actually going to use this side as our lower class limit and this one as our upper class limit. So let's go ahead and start out. So remember, your lowest data value was 61. So that's what I'm going to use over here, is this same number as my starting point. So this will be my lower class limit for my frequency distribution. Let's put this guy in the middle and give it a little bit more of a table look. We will do a frequency column next to it. Just make it look a little bit more like a table. And we're going down 10 classes. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which should be at 11. And we're going to put this as our 2 columns for now. If we need more, we can add more columns. So that's your lower limit. Now, remember when we were looking at this example here, I said when you're looking at your class width, you're going from lower class limit to lower class limit. That's how you're looking at your class width. So since our class width came out to be 20, it should be the difference of 20 from this class to the next one over here. So what you can do is, use that 61 as your starting point, and then just add that difference of 20 as your class width. So this should bring you up to 81. So this 20 is going to stay the same. This 20 is not going to change. And so because I don't want my cell to change, I can put a dollar symbol next to it. And this will always keep my cell where I have that 20 typed up the same, because I'm again going to use Google Sheets to help me come up with this remaining values. So I can literally just pull that cell down, and you will see as it moves forward, it's going to add 20 to each of your data values as it moves down. So these are all my lower class limits. So you can see I started at 61, which was my lowest class limit, and I'm using that same 61 as my starting point for my frequency distribution table. So just go with your lowest data value as your starting point over here in your frequency distribution. I think that's the best way to make sure, the lowest data value will be included in your table. Now, to come up with our upper class limits. So remember how we said there can be no overlap between the upper class limit here and then the lower class limit for the next one. So since this guy is starting at 81, that means this guy needs to end at 80. So I'm going to click on 81 as my cell and then just subtract 1 from it. Because, again, I'm going to let Google Sheets do the calculation for me. And it's suggesting an autofill, so I'm going to say yes. The only problem is I don't have an upper class limit over here because I had no number over here, right? So technically, this guy would have been 241 plus 20 if I had an 11th category. So this guy should be 260. So you can do a little bit of a calculation for that last one and just know that this guy here is going to be 260 since we don't really have this calculation over here to fall back on. So you can do these calculations by hand. And like I said, you can use Google or Excel to help you come up with these calculations. It's just up to you what you're comfortable with. But just make sure that when you're calculating your class width, that's going to be between the lower limits. So each one of these should be 20 units apart. And then make sure there's no overlap between the upper class limit from the previous one to the lower class limit from the next one. So just no overlap between these numbers over here. Okay, they should be 1 shy. Once you have this, now this is where we have to do our frequency calculation. Now for frequency, you can do, like your handout was showing where they're doing the tally marks. If you want to do that, or you can try and use a built-in function. So whatever works for you, you can try and do that. And this is where I do not like how Google Sheets does this, because if I try to sort out this column again, it's actually going to sort out my entire sheet. So it just does not just sort out the column, it sorts out the entire sheet. And I don't like why Google does that, but that's just one of those features. So what you can do is, if you wanted to sort this out, temporarily till you get all your calculations taken care of, I would say just go ahead and copy this over into a new sheet, where you have nothing else, and then you can sort this out. And now it's sorted, so you can see, okay, what numbers will fall into 61 to 80. So how many of them are going to be from 61 to 80? And of course, you can see there's only going to be one number because the next one starts at 163. So your frequency for the first one is just going to be 1. Then you are going from 81 to 100. So can you tell me how many are we going to have between 81 and 100? 0. Yeah, exactly, because you're starting at 163 for the next one. So you can see there's going to be 0 in here. For that matter, we are going to have a bunch of zeros in here. And I'm kind of glad that they showed up, because this is going to destroy our histogram, because you will have a little, and I'm just going to give you a rough idea. You will have a little bar with just 1 for this guy, but then you're going to have a bunch of zeros, and then whatever your next one is going to be, it's going to go up from there. So you don't really want to have these many zeros in your data set. And this is kind of what I was talking about, is where you will need to decide, okay, so how many classes should I have? So it looks like 10 classes is probably not the right number for us to go through, especially because there's such a big gap from our first data value to our next one. So here you can actually decrease it. And I know, Dennis, you had said 6. So let's go down and see what happens if we do 6 classes. So this one will have to be changed, because now you can see we're coming up with 32.6. So this rounds up to 33. And guys, you will notice that since I had used my cells to do the calculation, so I just picked the same cell as my lowest one to start with, and then in the next one I use the cell above it with my roundup cell of 33. So it already did the calculations for me. The only calculation it's not gonna update is this last one over here. So remember, this guy has to be the previous number plus this roundup value for our class width, 391, which means this guy is going to end at 390. So that will be a calculation you can do, on your own, which means we will need to update our frequency over here. 61 to 93 is still going to be 1. We're still going to have 0 here, and we're still going to have 0 here, because our next number begins at 163. So now you have to see, do I want to keep these 2 zeros? And if you don't want to keep those 2 zeros, then you will have to, decrease this down to 5 classes, and you cannot go any lower than 5. So for now, I would say let's keep the 2 zeros, and let's see what happens with these other values up here, and we can go ahead and then decide if we need to change our number of classes or not. So you're going from 160 to 192. And so that's going to be from 160 to 192. And you can see that's going to be a pretty nice number of values over here. So you would, of course, then need to count how many of these do you have in here. And it looks like we're going from 52 cell number. So that should be a total of 51 data values. And that seems to be maybe our largest group, I'd imagine. Then you would have to calculate from 193 to 225. And so this process can get a little tedious when you're trying to calculate these. Oh, I just realized we don't need these guys because we're only going to 6 classes, not 10 like before. Okay, so this guy was 258. And we don't need the last 4. And so in this case, you will see, and this is what I was telling you about, make sure your last class has room for your highest data value. So since we're going from 226 to 258, 257 will fall right in middle of that value. So we know we have room for 257 in our little table. So you do want to make sure you have that. So the method I'm showing you about calculating your cells, you can definitely use that. I am not a big fan of taking that much time to calculate each category. So what I actually use is a built-in function to do these calculations for me instead of, actually calculating this down. And it is called the count ifs function. So this is count ifs. And the way this works is you have to select your data cells first. And since we know our data cells are going to stay the same, I'm going to use dollar symbols around it. So I'm going from cell A1 to cell, I'm just using A100 because I potentially had copied 100 different values. So you select your cells and then you actually have to put in your criteria for what your lowest and your largest data value is going to be. And let me show you what that formula is going to be. I really don't want to copy over the whole thing. Actually, I don't think I have it in here. This is the wrong file. Oh, this is the one. Okay, so I've actually got this saved in a different example I have. Okay, so once you have selected your cells, this is where it kind of changes a little bit. So you select your cells and then you actually have to put what your greater than and your less than values are going to be from, what numbers you want to calculate it from. So again, instead of typing in numbers, I like using the cells again to help me, with the calculation here. So I know for my first cell, I needed to go from the smallest number of 61 to the largest number of 93. So I'm actually going to put my cell numbers, F2 and G2, instead of actually putting in 61 and 93. Because, again, if your data value changes or anything changes, you don't have to go in and then change each one of your formulas separately. So if you use the cell numbers instead of the actual value, it really makes your calculations easier. But you can see the general setup is the first part is you are putting in where are the cells where all your data values are going to be. So you can see that's going from cell A1 to A100. Then I'm telling you my number has to be greater than or equal to whatever the number is in cell F2. So that's number 61. And then I'm saying, okay, in that same data set from A1 to A100, find a number which is less than or equal to whatever number is in cell G2, which is going to be the number 93. And you will see it is going to calculate for us. And we don't have to use, sorting or anything like that. And we only had one value going from 61 to 93. And it's suggesting autofill because, again, I have used cell numbers instead of, the actual data value. So you can see it automatically types in F3 and G3 for us. In the next one, I've already got F4 and G4. So it will automatically pick the cells, as you go down your table. So this is another way of, working through your frequency. You can do the tally like it's showing you in your handout, or you can use this count ifs function that you have over here. And you can see when we go ahead and add up our little column over here, you should have a total of, what was it? We had 67 data items. So this total should come out to be 67. So again, I'm just going to use the sum function, and I'm going to add up this frequency column of ours. And you will see if your calculations are correct, if your frequencies are correct, they should add up to 67. So as we were anticipating, our category from 160 to 192 is our largest with 51 frequency. And then you can see from 193 to 225, we only have 12 values in there. And then the last one from 226 to 258, we have 3 people, 3 superheroes who fall into that high category. So this is basics of how you create your frequency distribution. And this is exactly what a frequency distribution looks like. Now, when they talk about, creating a relative frequency distribution, that is actually basically finding the percents, but in decimal form instead of a percentage form. And I know one of the examples they had that. I think it may have been the categorical one. Yeah, you will see how in this blood type example, they calculated the percents. So if instead of converting our numbers into percents, we left them as decimals, that's what we call as a relative frequency. So all you have to do to calculate the relative frequency is really simple. You take the frequency for each class and you divide it by the total number of your frequency column. So literally take the frequency for each class. And since my, value of 67 is going to stay the same, I'm going to put my dollar symbols around it. So the only thing that needs to change is the frequency for each class, but the number you're dividing by will stay the same. And it's going to give you an autofill option again. And this one actually should be a sum and not a frequency. So you can see again, when I add up my little relative frequency column, it is going to add up to a total of 1. So you can see again, I just copied over my value for, adding up that column, and it adds up to 1. So this is, again, like I said, your percents just in the form of decimals instead of being in the form of percents. But that's what your relative frequency column is going to look like. So your frequency should always add up to how many ever total data values you have, but your relative frequency column is going to add up to 100% because that's all your data values you're taking together, and it adds up to 100%, or in a decimal form would be 1. So the reason why I'm showing you this example and these calculations over here is, even though it's not a project for this week you guys are working on this discussion post, which is basically you designing a survey for yourself. So it can be, any topic that you choose, which, again, if you guys had not seen that, which hopefully you received the reminder message about this, is due today at midnight. So you're designing your own survey, you're coming up with your 3 questions that you would ask, what would be your population and your sample, and what kind of bias can you expect to see? That's this week. But what you guys are working on next week, which you will be turning in next Wednesday, a week from today, is based on this US candy production. And I have assigned each one of you 2 years worth of data. So you will actually have 24 values in your data set. And this is what you are going to be working on with this is you are actually going to decide how many classes you should have, what your lower class limit, what your class width, what your frequency distribution and relative frequency distribution is going to look like. And then you have to come up with, histograms based on those two values. So one histogram for the frequency distribution and one histogram for the relative frequency. So even though in our, example here, I showed you this as one table, technically these are two different tables. So you have one with just the frequency column and one with the relative frequency. But, instead of doing two different tables, you can do one single one. But when you do your histograms, when you do your chart, you will need to use one chart based on the frequency and then one chart based on the relative frequency. So you will be doing two separate graphs. So you guys are going to be working on creating your own frequency distribution and your relative frequency distribution. Based on that, you will have two different histograms to show. And then, of course, you'll be answering questions, what observations and stuff you are making from, what you come up with for your assigned data set. So this is going to be due next Wednesday, a week from today. And then also remember your chapter 2 exam is also going to be next Wednesday, right? So that's we started this week, you have this week, and then part of next week to get chapter 2 completed. Chapter 2 is not very long. It's 3 sections. This is actually one of our smaller chapters in this class. But this is what I wanted to show you. So that way, if you guys wanted to start working on your candy production assignment, so if you run into any trouble, need any extra help, you can always reach out to me for, questions and stuff like that. But that's basically the idea behind, creating these frequency distributions. So remember, they can be in the form of a categorical one or a group frequency distribution, which is what you guys will end up with on your US candy production. Now, based off of that, like I said, is where you create your histograms from. So your histogram, and I think this one is actually using the same example of temperatures in the 50 states. Yeah, so you can see they have their frequency, class boundaries. Now, since we're not really using class boundaries, instead of class boundaries, you guys will have your class limits on your x-axis over here. Of course, your frequency on the y-axis, and this is what your histogram would end up looking like. So, in those two classes where we had 0, 0 as our frequency over here, relative frequency, those graphs would, of course, look something like this, but instead of having even this little bit of height that you have here, and that's coming from because, they had a frequency of 1. In our example, since there will be a frequency of 0, of course, there'll just be a flat line. So you will have 1 for the first one, then, the next two categories would be 0. And then, of course, we had 51 for our next one. So it's going to end up looking something like this. But that's kind of the idea of why we usually try to avoid having too many zeros in our frequency distribution table. I'm hoping you guys will not have that problem in your data set, but again, each one of you is given a different data set, so it just kind of depends what kind of graph you will end up with. But this is basically, as you also saw in the handout from our 092 lab earlier, this is what a histogram ends up looking like. You should not have any gaps between your different vertical columns. And on your x-axis, you can see we basically are going from one class to the other horizontally, and then frequency will be on your vertical axis. And they kind of show you different graphs based off of that. So from a histogram, you can also draw a frequency polygon. And frequency polygon basically means you find the midpoint for each one of your class limits or your class boundaries. So that midpoint is literally going to be, halfway between the lower limit and the upper limit. And then, so if you mark your midpoints, and I'm just superimposing it on your histogram just to show you that that's kind of how this will come out to be. So you have your, like you were talking about earlier, kind of connecting the dots with straight lines. And so this is what your frequency polygon will end up looking like. And you can see that's exactly what we have over here. So you find the midpoints for each one of your class limits. And you can see these are the numbers that they come out to be. You can see that over here also. And you come up with your frequency polygon. The other one that we kind of base off of that is based on your cumulative frequency. And you come up with ogives based off of that. And this one actually just shows you, as a cumulative, as the name suggests, just from the beginning to the end, how if you keep adding your frequencies, where you are going to end up with. So your cumulative frequency literally comes from, and let's do that over here. And technically we should have midpoints instead of, our class limits here. But the way you do that is you start up with your first relative frequency, which is going to be 1, and then you keep adding. So what you are literally doing is in the second one, you are adding the first 2 frequencies. So this should be the first one plus the second one. The third one is going to be the first one, added with the second one, added with the third one. So you keep adding, as you move downwards on your list. So this guy would be, adding the first 4 now. And then when you get to your next one, it will be adding the first 5 frequencies. So by the time you get to the last one, you will have, the same number of total as your frequency column, because you will have added all of them together. So that's kind of how cumulative frequency works. So you just start with the first one, and then you keep adding the first and the second to get to your second one here. Then for your third one, it's going to be the first 3, the fourth one is going to be the first 4, so on and so forth. So that's kind of how the cumulative frequency works. And you can see when you try to graph it, because your numbers will keep increasing, it kind of shows you what the trend of your frequencies is going to look like. And this is what we call as an ogive. So they are just different types of graphs that are all based off of your frequency distribution. So you of course have your histograms, which is the most common graph you guys will see. And then some textbooks will talk about the frequency polygons and the ogives, and some do not. And I believe your textbook may not be talking about the ogives, but I just wanted to show you that, because that is one type of graph you can use with these different data values. So just for the same data set, you can see this is talking about the ages of the state governor. So again, 50 data sets in there. And you can see this is what your histogram looks like. This is what your frequency polygon looks like. And then this is what the cumulative frequency will look like. And this is based off of relative frequency. But even if you were using just regular frequency instead of the relative frequency, your graph should still look the same, because they will not change. One other thing that I do want to talk about, and we can come back and talk about the different types of graphs on Monday. But what I wanted to talk about is how your histograms can create different types of distributions. Because, again, remember, we're interested in how your data set is being spread out, because even the spread tells you a little bit about the data you are looking at, because we know whichever column has the highest value or the tallest column is going to have the highest frequency. So we know most of our data values are going to fall into that. Like for us, with the superhero example, we know most of the superheroes we're looking at are going to be anywhere between the height of 160 to 192, because that's where we have a maximum of our superheroes. And the chart, the graph will take a little bit of adjustment from you. I'm just going to show you where to find it, but you will have to make some adjustments to it. So this is not going to design the graph for us, but you can either go right here where it says insert chart. It looks like a little square with, bar graph on it. Or you can go under the insert menu option and go to chart from there. It doesn't matter. And a lot of times it's going to choose like a default graph for you, what it thinks should be important. But this is obviously not a histogram that we are comfortable with. So you will need to then go and, change your graphs based on, different things. And I'm honestly not even doing a good job of this. So you will have to kind of narrow it down to, what graph looks good, how to make it look like a histogram, can't have gaps in there. And so you will have to customize it, but that's just kind of a beginning to show you where you can find your graph. And obviously you can see our graph is wrong because it's not showing you the different frequencies we should have in there, but that's kind of a beginning of where, the graph you can find for these. So you will need a little bit of tweaking to come up with your graphs. I do want to show you under course information, if you go all the way down to tutorials and under additional technology tutorials, I have included some help information, how to create a histogram in Excel. If you guys are using Google, oops, sorry about that. If you guys are using Google Sheets, you can use this one over here. But, some of this will need a little bit of tweaking to, get the graph that you would want. I've also included 2 new lists over here. They just show you what the different functions are. So if you wanted to, look around and see what the list of functions for Google and Excel is going to look like, I have included that over here. So it gives you, all the different functions that are available to you in Google Sheets and in Excel. So you can kind of try looking around some of this stuff to help you out. But all of this is available under course information and then under additional technology tutorials that you can look at. So as far as the shape of the graph goes, you can see how we can have multiple different ways that your histogram might come out looking like. Now, not all of them are going to have, this perfect shape, but this is just to give you an idea. So you can see we have a bell-shaped over here, and we'll be talking about this a little bit more later on, but this is also what we would call as, normal distribution, or how, that looks like. So we'll get a little bit more detailed in this, but, of course, you can see this is your bell shape. Then you've got your uniform. So it's not like each one of your columns are the same height, but you can see they are close enough that we can call them as a uniform shape. The J-shaped one, of course, you can see is forming the shape of the letter J. So your tallest one is on the right-hand side, and as you move to the left, they get decreasing, in height. This would be the reverse J over here, graph D. So that's the reverse J shape. Now, right skewed over here, you will see is a different from your reverse J, because reverse J starts with the tallest column. Here, you're not necessarily starting with the tallest column, but of course you can see most of your taller ones are gathered on the left-hand side. And as you move to the right, it's tapering down, right? So it's kind of almost getting into more of a tail form. So it's starting on the left where the cluster is, and as you move right, it's tapering out, and it's getting into a narrow form. So this is what we call as right skewed, because on the right-hand side, it's getting narrower. This one here is called left skewed, because again, the gathering of most of your taller columns is on the right-hand side, but then as you're moving to the left, it's tapering out, right? So the tail is to the left. So that's why this is called left skewed. Then you've got bimodal, and we'll talk about modes, again in chapter 3, but this basically means you have 2 columns that are tall compared to all the other ones. And you can see they're showing that as about the same height on those two. So you've got bimodal, and again, you know, that means two. And then you've got the U-shaped one, because you can see again, you've got a little bit of a taller one here, a taller one here. And then as you move to the center, your columns are getting shorter, and then the smallest one is in the center. So because this is also one of the things I am asking you is to define what kind of a shape does your distribution have. And let me just show you that question very quickly. So this one is talking about, you know, make a comment on the shape of the distribution. So I am asking you to, you know, identify what does the shape of the distribution tell you. So this would be, you know, a great place to kind of give you an idea of what kind of distribution you are looking at, and you know what conclusions you can draw from it. So, you know, just look through some examples that are in your textbook or in your handout, and you can talk about, you know, what this shape is suggesting. You can see there's description for each one of these different shapes in your handout over here also. So this is kind of how we break down a frequency distribution and a histogram for, you know, organizing and basically displaying, presenting your data. And we'll get a little bit more detailed on Monday, but I did want to give you guys kind of a head start in case anybody wanted to start looking at and working on next week's assignment. So just remember, you are working on your discussion post this week. Start working on chapter 2 homework in my stat lab. I will be here, you know, I have another class after this. I'll be here at least till about 7 o'clock this evening. And if you need anything, send me an email, or I'll be here tomorrow if you have any questions, okay? So any questions before I let you guys go?
For the discussion post, are we just typing it up underneath, starting a new thread and answering the questions pretty much?
Yeah, for this week's assignment, I don't believe you guys are doing a video. Is there a link for a video? I know for the candy production there is, but I don't think you guys are doing a video response for the surveys. So yeah, you will just type it in the body. Just create a new thread for yourself and put in your survey questions and what kind of survey you want to work on. Okay, very good.
Okay, thank you.
Yeah, you're welcome. Anything else coming to mind, guys? Okay, so if you don't have any questions, then I will see you on Monday afternoon, guys. Have a wonderful weekend. Be careful and take care, everyone. Bye, guys. Be careful. Take care.
I did have one quick question.